Now I will tell Dr. Aditya Kumar Singh sir to tell something about this. Aditya sir.
Thank you, sir.
Yeah.
And respected resource person, Dr. Ashish.
Animesh Datta, sir.
Animesh Datta, sir. HOD Bhaskar, sir. Faculty member and students, good morning to you all. And I welcome you on this webinar. The topic of the webinar is distributed AI and agent technology. I am not associated with this topic. I do not have too much idea about the topic, but I hope that our faculty member and student would be benefited by this webinar. I am really thankful to the resource person. He has given us his precious time for the webinar. Thank you.
Thank you, sir. Now, without wasting the time, I am handing over the mic to Dr. Animesh Datta sir, and please go ahead with the session. Thank you, sir.
Thank you, Mr. Bhaskar, and thank you, Dr. Aditya Singh. Thank you very much for giving me these opportunities to be part of your department, your institute, and inviting me to give a lecture on distributed AI and agent technology. So this I have been working on this particular area for the last 5-6 years. I have 3 already produced PhDs in this topic. So some of the PhDs who completed their degrees with me, and there are 2 PhDs which are ongoing in this topic. So all are working on this area of distributed AI and agent technology. So this particular topic is very close to my heart, and the whatever experience I have with this topic and the publications we have, so that I will try to deliver. And of course, I'll be looking some more collaboration if possible with your universities or with your institute. So I have divided the entire topic into 3 modules. So first I give the brief the overview. What is my plan for the coming 4-5 days. So I have divided the total lecture plan into 3 parts. The first part is distributed AI and agent technology, the basics of agent technology, how agent technology comes from, and the motivation behind agent technology, why we say it is a distributed AI, what are the possible applications areas, what are the research components, and typically in which areas of this particular domain we are working, which are the problems where we are focusing currently, and what are the research challenges in this particular topic where people can work, maybe your student, your faculty members can work. So that will be 1 module. The second 2 module I will be picking up specifically from the work of my PhD student who did their research contribution on that particular topic. So those topics are some of the research aspect of this agent technology domain. So in this way, I divided the entire module. So I will start from the beginning of agent technology, then gradually we will be moving towards the research component of those things. So this is my plan. I already talked with Mr. Bhaskar that so taking the lecture class or webinar through online is a very boring task unless people interact with me, because I think taking classes in the lecture hall or lecture gallery, whatever, it is a two-way communication. It cannot be one-way communication. If it is a one-way communication, then nothing more than to watch a YouTube video. So I will be preferring that if while I am talking my slides, I will be expecting questions, interaction. Maybe I may not be able to give the answer for all the questions, but I will expect your interaction with the session. So that will also enrich my knowledge.
Okay, for everyone, please, if you have any question, you can send me the question in chat box. And if you want to tell in directly, then you can unmute your unmute request. You can send me unmute request, and I will accept that unmute request, and whatever possible, and I will then you will ask the question to the resource person. Okay, everyone, every students, you are free to ask any questions.
Yeah, so that is my requirement.
Yes, yes, yes.
Okay,
Thank
don't
you.
hesitate. Whatever the silly questions you have, and you can use your own language. I don't bother about that you have to ask the question in English only. You can. I am comfortable with Hindi, Bengali, at least at these two language. So you can ask easily any questions in Hindi. Okay. So this is all about. Now I'll start with a motivational example. Okay. So we are looking for a computing system where the example looks like this. Typically, a person is moving for a meeting with his boss. So the name of the person is Praful. I have a meeting with my boss and I am late. So this person is going to attend a meeting with his boss. So he is traveling very fast with his car. Suddenly he received a phone call from an unknown person. And the phone says, your wife had an accident. She is admitted at hospital in Powai. So the person immediately decide that I should inform my agent to reschedule the meeting. So the person Praful is requesting his agent that as today there is an issue in my family, so I cannot join the meeting with my boss today. So you please reschedule my meeting with the boss. So this message he gave to his software agent. Now there is a software agent in the phone or in the machine of Praful. In the same way, there is a software agent with his boss. Those software agents knows everything about their owner. So Praful's agent negotiates with the boss's agent and reschedule the meeting tomorrow. It informs your meeting is rescheduled to tomorrow at 5 p.m. Next, he is supposed to go to the hospital for his wife. So I still don't know where is he admitted in Powai. I should use my agent. Now, Praful agents contact a middle agent to find out some hospital in Powai having a recently admitted patient named Geeta. So Praful requests his agent that you please check where my wife is admitted. So Praful agents contact with the middleware agent to find out some hospital. There are maybe a number of hospitals in Powai area, but he is looking for that hospital where his wife is admitted. So the name of the wife is Geeta. The agent knows. So this agent contacts patient whose name is Geeta and who is recently admitted. After some time, the agent replied, your wife is admitted at a new Powai hospital, ward number 9. So that is the details of the patient as his wife. Next, Praful went to the new Powai hospital. So this is a motivating scenario where we are going. We are looking for some system where the system will do more for us, which is supposed to do that is being done by somebody else. For a summer vacation, I would like to go to Simla for 5 days with my family members and all. I have certain amount of budget and all. So what I did, I don't have much time. So I appoint a travel agent. I give all details that this is my requirement, this is my budget, this is my family members. You make a travel plan and everything. The travel agent is responsible for doing all sort of booking, starting from my home to the station, then train booking, then all the intermediate junction, then booking the hotel, taxis, local site, maybe 1 or 2 hotels. So everything will be done by the travel agent. So which is supposed to be done by me as an owner of the family, but I'm not doing. I am paying somebody else to do all my tasks. So that is the concept of travel agent or LIC agent in a normal life, which we are very much familiar. So we are in a computing domain. We are looking for an agent, the use of agent like this. So here, if you see this motivating scenario, you will find number of interaction. Here you see there are 2 agents. One agent is with the Proful's machine, another agent with the boss's machine. When Proful finds that he is not able to attend the meeting today because there is an accident in his family, so he immediately tells her agent that you please reschedule the meeting with boss. Then the Proful's agent immediately contacted the boss agent and negotiate their availability. So when there is a meeting, there is a need to find out the common time. So the agent which is running in the boss's machine, he knows all about the schedule of boss. Similarly, all the availability of Proful is known to the Proful's agent. Should they start negotiating what is the preferable time when these 2 persons can meet? So these tasks supposed to be done by the human being, the Proful. But instead of doing this task, Proful himself, he is delegating the task. He is delegating the task to someone else who is doing on behalf of him. After this, the same thing you see when he needs to find out the name of the hospital or the ward number of the hospital where his wife is admitted, he asks his agent, you please explore all the hospital information and you give me the name of that hospital and the ward number where my wife is admitted. The Proful agent knows the name of his wife and also the information of all the agents which are situated in different hospitals machine. So he immediately contacted the middle agent. So Proful agents contact a middle agent to find out some hospital in Powai having recently admitted patient. And his reply is, your wife is admitted at a new Powai hospital, ward number 9. So this task again is supposed to be done by the person himself, but he is not doing that. Instead of that, he is appointing an agent, here the software agent, who is doing the task on behalf of his owner. Here the owner is Proful. So we are looking for some computing device which will be like this. Okay, so based on this motivational example, we will be starting the basic of the agent technology and distributed AI. So this is the main content of the presentation. So if you see the modern computing is based on these 5 trends: ubiquity, interconnection, intelligence, delegation, and human orientation. These are the 5 trends of modern computing. Ubiquity. So ubiquity is the computing is everywhere. Today, whatever electronic device you can see, there is a part of a computer. Maybe it is in a very small form, but it is having a computer. Today, if you think of a very, low-end car, the Tata Nano, that is also equipped with a computer which is controlling the MPFI, the fuel injector. Don't need to think about the very high-level car. Whatever device, whatever electronics device today you have, it is equipped with computer in it. So there are mainly 2 reasons for that. The cost of processing power decreases dramatically. As per the Moore's law, in every 18 months, the cost of computing power or the processing power will be doubled with the same cost. So that allow to produce more powerful computers with a lesser price. This is one aspect. The second aspect is the size of the computer is getting lower. Even today, a mobile device, smartphone has a computing power like a desktop machine. So computer is everywhere, in every devices. It is in micro oven, it is in webcam, it is in television, everywhere. Freeze, everywhere you have the computers. So that is ubiquity. The computer is available everywhere. Every electronics artifacts you can find, there is a computer inside it in any form. Whatever small it is, whatever the power of memory it has. So there are 2 reasons. One is the cost of computing is getting lower and lower. And the size of computing is also decreasing exponentially. So that is ubiquity. The second trend is interconnection. Today, computer is nowhere a standalone machine. Even I normally ask this question in my distributed system class to the MTech student. If you are given a computer and said that this computer doesn't have network, do you accept it? So the obvious answer is no. Because without the network, there is nothing but a garbage for your home. You cannot think a computer without a network today. And whenever you have a network, you are able to connect your computer with a remote computer to access the resource. The resource can be file, can be database, can be movies, can be whatever. So that is your interconnection. Computer system today no longer standalone, but are networked into large distributed systems, starting from banking system, mobile, ATM, whatever. YouTube, Google Chat, Zoom, Skype, whatever. And along with that, it is same like with the Moore's law, cost of sending a packet from one machine to another machine is getting less and less. If you think that 5 years back, if you do internet on the cyber cafe, the cost was much higher. But today, with the 10 rupees, you can chat for 1 GB data. You can use 1 GB data with the 10 rupees or 12 rupees. But 5 years or 10 years back, you think that you need to spend 70 rupees or 100 rupees to use 1 hour internet. And due to availability of high-speed network, the fiber optic network, the connectivity is also very fast. You can easily see an high definition movie, high definition movie, high resolution movie sitting at your desktop online. The third is intelligence. Intelligence or the artificial intelligence. The complexity of the tasks that computers are capable of doing has grown steadily. It is the capability of a computing system. It is the capability of the computing system to perform complex tasks which the human mind can solve. For example, today you can design a, what do you say, chessboard, which can plan for thousands steps at a time. More and more complex tasks can be solved by computer system. So due to the advancement of the algorithms, complex algorithms, the capability of the computer system to solve this complex problem is also increases drastically. So it is the capability of a computer system to solve complex tasks. The fourth is a delegation. Computers are doing more for us without our intervention. The most modest example of this is Google car. Even many of the companies are coming with a driverless car. So people are giving more and more tasks which are supposed to be done by the human being to the computers. Fly-by-wire aeroplane where you don't have the pilot, or the flight is running by an autopilot or a computer. It's called fly-by-wire. Fly-by-wire car, you don't have the driver. The driver parts is controlled by a computer who can sense the environment, and accordingly it can perform. It can change the steering, it can change its accelerator, it can change its braking position. So we are going to delegate safety critical tasks. The tasks are which are safety critical, which are related to human life. Safety critical tasks to the computer to perform. As I said, fly-by-wire aeroplane or autopilot computers. So delegation of tasks. Fifth is human orientation. Today we are using computers like a human being. To use a computer, you don't need to be a computer scientist or computer engineer. The GUI of a computer is so easy, so user-friendly that a very marginalized education person can use it. He doesn't need to think about the technology behind it. The GUI part, the speech recognition part, and the object orientation part that enables a person to use a computer like a human being, as if he is talking like a human being. But 10 years back or 20 years back, the computer was not like that. You need to have sufficient knowledge about the command, maybe the Linux command or DOS command or kind of thing, then only you can interact with the computer system. But today you don't need. The GUI is so advanced. There are speech recognition system. You don't need to touch the machine also. So we are using the computer just like a human being. The way we give our instruction to our subordinate staff or friends or family member, in the same way we are using the computers today. 10-20 years back, still people can remember that if you have to wake up in the early morning, you need to request your parents that you please give me a call or something like that. Today you didn't just give an alarm to you, set an alarm in your, and you can wake up. You don't need to think. You can give a lot of reminder in your system. Maybe birthday reminder, maybe your meeting, everything you can do with your mobile phone. And for that, you don't need to be a computer engineer. So that's why it's called human orientation. The computer is behaving like a human being, and we are habituated with this thing. Many people are using, I don't have, but I have seen many of my friends, they have a laptop which is a touch screen. So they don't use the even mouse or touchpad. The computers are so smart that just you can touch your finger on the screen and it will work. The Windows, Linux, everything, every operating system it has. So that is human orientation. It is like a human being. It behaves like a human being. It can listen your words. It can recognize your speech. So if you see the difference between 100 millions of people connected by email once seemed to be in science fiction. 20 years back, it was a science fiction to think that 100 million people connected by email once seemed to be a science fiction. Similarly, maybe today science fiction will come true one day. The example that I have given, maybe today you are feeling that it is a science fiction, that somebody is telling his agent to fix the meeting. Somebody is telling his agent to check where his wife is admitted in the hospital. So today you may feel that this is a science fiction, but 20 years back, it was also a science fiction. The Facebook was a science fiction. We cannot think even this Zoom meeting, I mean, 10 years back, this Zoom meeting or the Skype meeting was a science fiction for us. We cannot think. And to add more on it, I would like to add some more example that this crisis period of COVID-19 put the small children to use the computer so efficiently we cannot imagine earlier. My daughter, who study in class 2, she is attending all her classes online. Once I start the machine, the remaining thing she does herself. We don't need any intervention with her. She can change the class from one class to another class. When she needs to talk with her teacher, she can unmute. So their classes used to take place in Google Meet. The screen is so user-friendly that a small kid of 6 years or 7 years can easily handle that. So today what looks like a science fiction, tomorrow will come true. Now, so from the perspective of human orientation, if you see the evolution of computer system from the programming perspective, 50 years back, or maybe in 1950s, when the programming concept come in computer, it was not like today. It was something like you have some mechanical switch. You have some mechanical switch, and you have to literally put the switch on off to write your code. The code is just a 0-1 code. You don't have had any kind of language, whatever today we have. you have some kind of switch. You can put the switch off or on to write the code. Today we may think that in 1950s the people were so foolish that they write the code in that way. Is it possible? But yes, that was possible in that time. And from that perspective, if you think, today was the science fiction. So that was, so you writing a code was really a tedious job. You need to know the internal architecture of the memory. You need to know the internal architecture of the processors. So everything you need to be very clear, then only you can write the code. That is called machine code. So you need to have a very clear concept. You are writing your code. After that, you have come the assembly language, which is little bit of English-like. The first English-like. Hello.
Yes, sir, it is
Hello.
coming. It is, yes,
Yeah,
sir, it is
I think somebody has muted me.
yes, yes, yes.
So,
Listen.
so the next programming language aspect is the assembly language, which is something like English-like language, but you need to remember a lot of machine-dependent code, kind of opcode, operand, everything. So that is also based on some machine. So if you write a code for a particular machine for a particular purpose, that code will not run when you go to second machine. So writing the code was dependent on the machine architecture, machine design, machine memory, processors, whether it is a 32-bit machine, 64-bit, 16-bit machine. After that, the first machine independent programming language come, which are Fortran, COBOL, etc., where you don't need to think about the machine. You can write your code. Once you write the code, it can be executed machine X, machine Y, machine Z. You don't need to think about the machine architecture. So this type of language is COBOL, Fortran. And then you have subroutines. Program with a part of the code is named separately as subroutine, which you can call any number of times. Whenever you require, you can call. Then you have procedure and function, like C programming language or kind of thing, where you can define your separate function. And then comes to abstract data type, where you can create your own data structure. You can create your own data structure like array, you can create your linked list, whatever. Queue, stack, you can create your own data structure. Then it comes to the object. Object is something like the society we have. In the society, the way we treat an object, my mouse is an object. Computer keyboard is an object. It has some functionalities. So whenever necessary, you can invoke those functions. You can invoke those methods. So after abstract data types, you come the object-oriented programming like Java, Python. Is that these are object-oriented programming language where each and everything you have to define as object, and each object will have some kind of method. Whenever you need to perform some operation, the object needs to invoke that method. And there are a lot of other features in the object orientation, like class hierarchy, then object-object relationship, this type of things were there. And after that, the concept of agents come in the picture. So when you think about the object is something like is a passive entity. Whenever you need to do, when you want to perform some operation with the object you need to invoke that method. It cannot sense the environment. For example, the mouse, this mouse, there are some operations, maybe left key, right key, the scroll down. So these are some kind of methods that are associated with the object mouse. When I need a particular operation, I will perform maybe right click, I will perform the left click, or maybe the scroll down. But when you think about the agent is something different. When we say agents, it has some kind of autonomy. You don't need to say each and everything to the agent. You need to say what you need to do, but you don't need to say how you need to do. That means you are putting more and more abstraction on object, such that the object can act autonomously. And when an object will work as an autonomous system, we will say it is an agent. That means you are putting some more abstract layer on the object. You are putting some more abstract layer on the object that will leads to an agent. You don't need to say repeatedly that this you have to do and how you have to do. You just say, I need this function. For again, if you go to the first example, the first motivation example that today we discussed, the owner of the agent tells that I need to reschedule the meeting. That's it. Now, agent knows how to reschedule the meeting. He knows the availability of his owner. He contacted the agent of the boss. They negotiate with each other. They fix up the date and they inform their owners. So each and every step you do not need to say. So that is the notion of agents. Now, so if you see this particular slide, you will find that we are moving from machine orientation to human orientation. From the early 1950s, you find that you need to write the code, machine dependent code. Then gradually you are moving more and more abstraction, and you are coming to a position where your system can think what it needs to do. You don't need to say repeatedly how to do. So you are moving from machine orientation to human orientation. You are moving from machine orientation to human orientation. That is the beauty of agent technology. And that leads to the necessity of agent technology. So if you have any questions, Mr. Bhaskar, could you ask the
sir. So till now, is there any question to anybody? Actually, sir, you have given the lecture flawlessly, sir, and even me also, it is very new topic for me also, and clearly I understand and that all these things, and that's very interestingly I have understand that. And
so if I am going very fast, you please let me know.
No,
without
sir,
any hesitation. Without any hesitation.
No, sir. You are
because I am not very conversant with this online lecture and all. I am very frankly, I am telling you, I am not very conversant with this online lecture and all.
okay, sir.
Maybe for the last couple of years. I have been doing a lot of meeting with the international professors and all through online. But this giving this lecture with a group of student or audience, that experience I don't have much. So I don't know whether I am going. No, whether I am going very fast or whether I am going very slow, or whether I don't know.
Very rightly you are going, sir. And so everything you are showing clearly visible and understandable. All these things.
So if you have any questions,
any question, students? Any question? You can write in chat box, or you can tell directly. Unmute button by clicking unmute button. Anybody?
I think somebody raised questions. Which language are going to be demanded in future the most? See, the thing is, which demand? See, some people. I mean, the name I uttered at the beginning, that some of my PhD students who worked on this domain, some of them developed the code using Java itself. Okay, so Java has a framework called JADE, Java Agent Development Environment, JADE, Java Agent Development Environment. Okay, so there you have the features where you can create your own agent code. You can create your own agent. You can deploy the agent in number of machines. And you can do some kind of interaction among the agents. So I will be going more detail about this thing, at least in the theoretical perspective. So JADE is one. Similarly, Python-based agent programming framework is there, SPADE. Smart Python Agent Development Environment. Okay. So, so we are moving from machine orientation to human orientation, and that leads to the agent technology. So where does it bring us? Delegation and intelligence imply the need to build computer systems that can act effectively on our behalf. Delegation and intelligence imply the need to build computer system that can act effectively on our behalf. Again, if I go to the same example that we have started at the beginning, somebody raised the questions. Good morning, sir. Sir, what kind of database are going to use in AI? See, somebody asked the questions, what kind of database are going to use in AI, means SQL oriented. So you can use any language, any database language. That is not the issue. Issue is the more complicated issue is what is your objective with the agent? What you want your agent should do for you, that you need to define very clearly. Why you want to deploy an agent? So designing the agent is more complicated. What language you will be using, that is you can use any language. I mean, language or the database is not a very big deal. You can use the graph database also. You can use SQL database, MySQL database. That is not an issue. Issue is how to design the agent. I mean, what is the purpose of your agent? For what you want to delegate to him? What you want to delegate to him? For example, you want to deploy an agent in your mobile phone, which will read the birthday of your all your friends list in your WhatsApp, and it will send on WhatsApp wish to each and every person who has the birthday on particular day. And that birthday wish will be different from one to another. So you can deploy, instead of writing your own WhatsApp message for wishing your friend, you can write an agent. I'm just giving a small example. You can write a small agent who will do on behalf of you. So every morning it will check who has the birthday today. Okay, this person has the birthday today. So depending on whether he is your friend or maybe your elder or whatever, he will give a wish message. So that is your objective. So first you need to think about that what is the purpose of your agent, why you want to build an agent, and what type of task you want to delegate to your agent. That is more important. Okay. So delegation and intelligence imply the need. Delegation and intelligence imply the need to build computer system that can act effectively on our behalf. First, you have to delegate the task. Just like the example that I have given in the beginning. Proful, the owner, meeting as what is the Proful is delegating his task of rescheduling the meeting to his agent. So delegation of the task. Second, his agent has the intelligence capability to interact with the other agent and negotiate with their timings to find out a common time frame of the meeting. So here you see, in this example, you have the delegation, task delegation, and intelligence in the agent to work on behalf of the owner. Here owner is the Proful himself, because the agent is working for Proful. So this implies the ability of computer system to act independently. You don't need to say repeatedly what to do, how to do. Just you say what you need, the agent will do everything for you. The ability of computer system to act in a way that represent our best interest while interacting with the other humans or system. An agent can interact with the other agent. An agent can interact with the other agent. An agent can also interact with a human being. So it is, if you say an agent is a machine or computer resource or computer processing, so it is an communication between agent to agent or machine to machine. It can be an interaction between agent to human being or human being to an agent. The ability of computer system to act in a way that represent our best interest while interacting with other humans or system. Yeah. So computer science expand. These issues were not studied in computer science until recently. All these trends have led to the emergence of new field of computer science called multi-agent system, where you have more than one agents. So one agent is not capable of performing the task that you want to do. Rather than you want more than one agents. So what is the definition of agent? An agent is a computer system. An agent is a computer system that is capable of independent action on behalf of its user or owner. An agent is a computer system that is capable of independent action. Mind it, the term is independent. the owner does not need to say how to do. It will say, this I need to do, this you need to do. While you delegate your task to your travel agent for booking a ticket or booking a tour plan for your family, booking a train, flight, hotel, etc., car, all these things, you don't need to say repeatedly how to do. You just tell the travel agent that this is the number of my families, this is my requirement, this is my budget, this is the duration that I want to stay, etc., etc. Now the travel agent knows everything. For a tour of 5 days to Simla, what he needs to do. If instead of Simla, if it is a Srinagar, the tour plan will be different, and accordingly travel agent will make the tour plan for you. Instead of 5 days, if you want to stay for 10 days, the travel agent will make the plan accordingly. So depending on the requirement, the travel agent will make the plan for you. In the same way, if you bring the analogy in computer system, an agent is a computer system that is capable of independent action. It's capable of independent action on behalf of its user or owner. So agent is capable of independent action. Agent action is purposeful. It is doing with some purpose, with some goal, with something to achieve, with something, some objective to achieve. One more definition. An agent is anything that can perceive its environment through its sensor and acts upon that environment through its effectors. An agent, it can sense the environment through its sensor. It can sense the environment through its sensor. After sensing, it will do some kind of computation and decide what to do on the environment, and an action will be taken on the environment. So an agent is anything that can perceive its environment through its sensor and acts upon that environment through its effectors. So this is an example of multi-agent system, where instead of single agent, you have a group of agents called multi-agent. A multi-agent system is one that consists of number of agents which interact with one another. If you see the example that I have started with my today's lecture, Proful's agent is interacting with the agent of the boss, and they are negotiating with each other to achieve a common goal. What is the goal? To fix the meeting timings. So fixing the meeting timings is not the job of a single agent. It needs to interact with the other agent for their availability of their owner, to know the availability of their owners. So there can be a lot of such activities where single agent is not capable of doing all these tasks. You need to deploy more than one agent. That is called multi-agent system. A multi-agent system is one that consists of a number of agents which interact with one another. Next, agent autonomy. A system is autonomous. A system is autonomous if it requires little help from human user. If we don't have to tell it what to do step by step, You don't need to say the agent what to do. I mean, step-by-step procedure. If it can choose its own goal and the way to achieve it, if its behavior is determined by its own experience, that means it can learn by experience. Over the time, it can learn from the experience that what it did earlier. If you don't understand its internal working, as an owner, I don't need to understand the working principle of it. I purchase an agent, I deploy an agent. I don't need to know the internal architecture of it. It is so abstracted. The detailed internal architecture is abstracted from the user or the owner. So here it is purposefully it is written like this, that the owner is not the designer. Designer is the person who designed the agent, but owner may not be the designer. You may be the owner of an iPhone 6, but you are not the designer. You are using all the functionalities of iPhone 6. So you don't need to know the internal architecture of iPhone 6. What you need to know, the working principle, or I mean, the way you are interacting with the phone, the functionalities, the features, the GUIs, that you need to know as an user. You don't need to know the internal architecture of the phone. So a system is autonomous if it requires little help from the human user. If we don't have to tell what what to do step by step, if it can choose its owner goal and the way to achieve it, if its behavior is determined by its own experience, if we don't understand its internal working. Next, when you say an agent is an intelligent agent, there are three desirable properties to call an agent is an intelligent agent. Intelligent agents should respond in a timely fashion to change they perceive in their environment. This is called reactive. It will react depending on change on something on the environment. That is called reactive agent. Reactivity. It will react on the change of environment. The second is proactive or proactiveness. Proactive, instead of reactive behavior, the proactive is the agent is goal directed. It has something in its mind and accordingly it is performing the task without thinking about what is happening in the environment. It has certain in his let's say the mind to achieve the objective, and accordingly it is performing the task. Intelligent agents can take the initiative to meet their design objective and they exhibit goal-directed behavior. I have something in my mind and accordingly I am doing. For example, I may be called as an agent to have this 5 days lecture plan with you. I am preparing for the last 1 or 2 weeks that what type of material I should plan, how should I plan, because as an individual person I have the autonomy. As an individual person I have the autonomy, I have the intelligence to perform the best in front of you, and accordingly I am planning. Nobody is telling me that you have to do in the best. I have that level of intelligence that as these people will be attending my lecture, sure, I should do my best performance, whatever way I can do. So that is the proactive behavior. I have something in my mind as an objective, and I am going to achieve that goal. Okay. The next is social ability. Intelligent agent can interact with the other agent and humans to satisfy their design objective. Just like in the family or in the society, we are not alone. We have many people in the neighbor. In the family also, we may have parents, wife, daughters, sister, whatever. So we have the capability to interact with each other. We have the feelings for each and every person of my family. We belongs to a particular society where we have some common understanding how to keep the society clean, how to keep the society neat and clean, peaceful, everything. So as a result, occasionally we go for a meeting once in a month or twice in a month, like this. So intelligent agent can interact with other agent. Here other agent can be human or the agent. That's as I said earlier, that it can be an interaction of agent to agent, or it can be interaction of agent to human. So agent to agent can be interaction can be there, or agent to human being interaction can be there to satisfy their design objective. So in a nutshell, we will say an agent will be called as an intelligent agent if it has three properties: reactive properties, proactive properties, and social abilities. So this is an example of thermometer in a public place or in a home, which can sense the environment, the temperature of the environment, and will display. It is a thermometer. Can we say it is an intelligent agent? We can say it is an autonomous, of course. You don't need to say repeatedly what to do. It can easily sense from its sensor. It can sense the environment, it can compute, and it can display through its actuators, through the display screen. So we can say it is an autonomous agent. But the question is, can we say it is an intelligent agent? The answer should be come from three: reactive, proactive, social ability. If you see these three properties, this particular example will satisfy only the first case, the reactivity, not the remaining two. Intelligent agents should respond in a timely fashion to change they perceive in their environment. It is showing 72 degrees Fahrenheit. The next moment when it says, see that there is a change in the temperature, it will respond accordingly. So we can say it is a reactive agent, but not proactive of social ability, because here there is an only single agent. There is no question of social ability. That of course autonomous agent we can say. Purely reactive agents. A purely reactive agent means decision only on present state. What is the condition of the present state? Accordingly, it will take the decision. It will not keep anything in the memory of the earlier, or it cannot learn from earlier. It will not be goal directed. It doesn't have any objective in the mind. So the example of reactive agent is a thermostat, or the example that I have given even. This is. is a thermostat with two environments. Thermostat that are put in a AC, air condition. If the temperature goes beyond 32 degrees centigrade, it start working. If it within 27 degrees centigrade, it will not function. The fan mode will work. So this is an example of thermostat is an example of purely reactive agents. So what is an environment? The environment is the entity in which agent is situated. Any environment where the agent is situated is called an environment. It is this environment that the agent senses and acts. So if I say this is an agent, it can perceive the environment through its sensor. An agent is perceiving its environment through its sensor. Based on that, it is doing some kind of action on the environment. It's called effectors. Effectors, or sometimes it is called actuators. Next, classification of environment. It can be accessible environment, inaccessible environment. If an agent can obtain the complete and correct information about the state of the world, then we will say it is an accessible environment. If the entire environment is not accessible by the agent, then we will call inaccessible environment. So there is a domain of area called partial observability. How an agent can take the decision when it doesn't have the complete information or it has a fuzzy information. So a group of agents working together for a particular purpose, but none of the agents have the complete information of the whole. But still they need to go achieve their goal. So how they fulfill their objective? With partial information. That can be a research objective or a research direction to work. Deterministic versus non-deterministic. Do action have guaranteed and uniquely defined effects? If I can determine that if I do a particular action, then what changes will be there in the environment, then we will say it is a deterministic. For example, chessboard. Two persons are playing chess with a particular scenario in the particular settings in the board. I know if I take this action, what will be the change in the whole board? I can assess, I can determine. Or even I can determine if I take this particular step, then what are the probable steps that the opponent can take, that I can determine. But if it is a game of playing cards, I know what cards I have and accordingly I can play, but I don't know for the cards of the other member. So based on my action, what will be the change in the environment, I cannot determine. I can just predict. I can predict, but I cannot determine. Because most of the environment is not accessible to me. Apart from me, there are other three members sitting on in the game. So what are the cards they have? I don't know. So always working on a non-deterministic environment is complicated and computational hard problem than working on the deterministic environment. Similarly, static versus dynamic. While an agent is taking some action, whether the environment is changing during that period. If it is changing during that period, then it is said as dynamic environment. And if the environment remains fixed, static for a period during the taking the action, then we will say static environment. Then you have some other other classification like episodic and non-episodic. In episodic environment, each action is treated as an episode. The first episode will not affect the second episode. Even if the first episode fails or there is an error in the first episode, that will not affect the second episode, because each of these phase will be treated as an episode. If it is a non-episodic, then each of these episode, if there is a change in first episode, that will affect to the next. So these are non-episodic. Same, you have discrete and continuous. Is the number of action and percept fixed and finite? Then we will say discrete. The example of discrete episode is a discrete environment is chess game. Open environment. If the environment is inaccessible, non-deterministic, and dynamic and continuous environment, then we will say it is an open environment. So working on open environment is tough and challenging work. Okay, now you'll gradually moving to the computer system. So what is an abstract agent architecture? Assume a discrete finite set of environment E, which is a collection of set of environment E, E dash, E double dash, like this. Assume action an agent is performing. So AC, that is a collection of alpha, alpha dash, alpha double dash, like this. Environment start at some state and agent choose an action. If you think the chessboard, in a particular time frame, the chessboard looks like this. The setting of the chessboard looks like this. Based on that, agent is taking some kind of action that will change to some next step. So it will changing the environment. Based on the environment, another agent is taking some kind of action. It will also change to some next environment setting. This is called a run. Sequence of interleaved environment states. Environment states and action, sorry, action was deleted. Is a sequence of interleaved environment states and action. For example, initially the environment state was E naught. On that E naught environment settings, the agent takes an action alpha naught. It changes to an environment E1. In E1 settings, the agent takes another action. It should be different actually, alpha, alpha naught, whatever values, different actions. It will change it to E2. So in this way, it starts from E naught. After a set of environment change and action, it leads to a final environment settings EU. That complete movement from E naught to EU by a set of action is called an R. R is a run. and define R, capital R. It can be number of such run. Define R is an it has the set of all such possible finite sequence. It can be number of such sequence, and that ends with an action and environment state. It leads to an end with some kind of. So we can write a state transformer function is finite sequence of this R with some action, and that leads to some environmental settings. So this function pi maps each run ending with an agent action to the set of possible resulting states. Depends on the history of previous state, uncertainty, and non-deterministic model by allowing multiple successor states. So it starts from one state, it takes some kind of this action, it will leads to some final state. So now this will be determined by a state transformer function pi. I think. So abstract agent architecture in general, in most general sense, an agent is a function. In a language of computer science, we can say, in a language of computer science, we can say an agent is a function which maps from an AC to an AC. If set of all agent is AG, define system as a pair of agent AG and an environment ENV. Denotes run by system are AG and environment set, a set of agents and set of environment, and assume they are all terminal and thus finite. Okay, so this is more, we can say two agents AG1 and AG2 are called behaviorally equivalent if equivalent with respect to an environment ENV if R AG1 an environment R is the run, AG2 an environment, both are equivalent. Then we will say that these two agents are behaviorally equivalent. Okay, so I think this much for today. So if you have any questions, and we can have discussion. So maybe tomorrow we can start from multi-agent system.
Okay. Anybody have any question? Any students?
Hello. Hello.
Yes, sir.
If you have any questions, or if the student or the members, the department wants to interact with me, I am available now. Based on the today's discussion, whatever we have.
Anybody have any question? Any student, please ask in the chat box. No questions. Okay. One questions. One questions I have, sir.
Yeah, sure.
Sir, can you back to the slide?
Just a minute. দেখুন তো আসছে?
Yes, sir. Previous slide. Previous slide. Okay, sir. Okay, sir. Sir, accessible and inaccessible. Actually, can you repeat the example of accessible and inaccessible? Because slightly I have missed that particular point.
If you think of the typically think of a distributed graph coloring.
Yes, sir.
Distributed graph coloring. Graph coloring problem with distributed instance. Distributed instance, that means each node is running in one computer. I know what color I have. I know the color of my neighbor, immediate neighbor. I know the color of my immediate neighbor, but I don't know the color of all the nodes. I can access my neighbor only.
Okay, sir.
So in distributed system, in general, not only multi-agent or agent system, in a distributed system, nobody has the knowledge of the whole system. Everybody knows the part of it. I know some part of the system, not the entire part. You are running, you knows some part of the system. Somebody else, he knows some part of the whole system. So without knowing the complete knowledge of the whole system, we need to come together for a common objective. For the common example is the distributed graph coloring. You can treat the graph coloring problem as a centralized problem. You can treat the graph coloring problem as a centralized problem, as well as you can treat it as a distributed problem. If you treat the graph coloring problem as a centralized problem, a centralized system, then every node has the knowledge of all the node. Every node has the knowledge of every node. If it is a centralized system. But if you talk about the distributed graph coloring, then a single node knows only the color of its neighbor node.
Yes, I can understand, sir. And sir, can one agent be accessible, deterministic, and static, all three? Interrelated environments?
It can. It depends on the design aspect. Okay. If you, the most important issues for this domain, the two aspects. One is agent design, another is the society design. For what purpose you want to design your agent, and whether the single agent is sufficient, or you need to deploy multiple agents, or you need to put multiple agents in multiple nodes. Maybe your agent needs to interact with the other agent. In that case, you need to go for society design. So depending on the requirement of your system, you need to go for individual agent design. This is first paradigm. The second paradigm is society design. So it's a kind of, we are looking for some kind of artificial society where instead of individual human being, we will be deploying individual agent.
Yes, sir.
For example, yesterday you have sent an email telling that today is the class at 10:30 with this Zoom link. Can I deploy an agent on my email server such that he knows everything about me? He knows that Animesh Datta is supposed to give the lecture, already he committed. So immediately we will be attending. So first thing, what I need to do, I need to find out the requirement of my agent, what I want to achieve through this. And does a single agent can do that? If I need multiple agents, then we need to go for society design. And when we need to go for society design, just like a human being, we need to think about this design. We'll be discussing tomorrow. Interaction, coordination, competition, collaboration. And all this can be achieved through only communication. But this society design is applicable when you go for multiple agents, not the single agent. Single agent concept asana. Single agent society concept asana, interaction concept asana. You don't have the communication unless you have your somebody. How can you communicate?
Okay, sir. Okay, sir. Okay, sir. Anybody, do you have any kind of questions? Please, you can ask. Otherwise, we can proceed for tomorrow.
If the faculty members have any questions, they can ask also.
Yes, any faculty members? I think, sir. Okay.
Okay.
Yes. Okay, sir. Then
Okay.
thank you for this session actually, and
Okay.
for if you are giving us time from your busy schedule actually.
No, that is not
really
okay.
very
It's
happy.
okay. But the most important thing, how much I can reach to you, that is the big question. I mean, as I'm not very
Actually,
comfortable with.
Actually, sir, it is very nice session. What I am telling again, even all the participants also privately they can telling in chat box that very nice session sir is giving and explaining very nicely, and even you are giving these real life examples. That is very nice. Whatever
Yeah,
you
so,
are giving real life
yeah.
examples.
So tomorrow and day after tomorrow, we will be gradually moving towards the research aspect of it, where my students are working.
Yes, sir. Yes, sir. Yes, sir. Okay.
This coordination, collaboration, I think that will be more interesting, and it's a kind of some algorithms or mathematics where the computer science people are more interested on.
Okay, definitely, we are
today
for that.
most of the thing I am just going through kind of history class.
No, sir, it is very interesting.
So, because unless this history you cannot,
yes.
I mean, I cannot go through this the direct algorithms or the mathematics part of it.
Yes, sir. Actually, students are also there. They does not know even what agent is, agent technology, what agent is. That's why actually this session is very mostly needed.
You tell your student as well as the faculty members. I mean, they may be available online. So I have my mail ID there or in my website. You can, if they have any questions apart from this discussion, they need to know anything. If they need some kind of paper on that or anything, whatever.
Okay, sir.
Without hesitation, they ask them to send me an email. Immediately, they will get the response from me.
Okay, sir. One faculty members of our department, Susmita Palmal ma'am, he has asked that if PPT will be available.
Yeah, sure.
Okay, sir. Okay, sir.
So at the end of the session, I will send all the PPTs. Don't worry.
Okay, sir. Okay, sir. Very nice. Thank you.
Okay. Thank you.
Okay, sir. Then we will proceed to the next session.
So tomorrow at the same time, 10:30.
Same time, and I will send the link also. Sir.
Okay, so link will be changed.
I think.
Okay, no problem. I don't have any issue. That is
okay. Okay, sir. Okay,
just let me know.
Okay, sir. Thank you, sir.
Thank
you everyone for participating this webinar and make this webinar successful. And this hope you will enjoy. Okay, thank you, sir.